Hello and welcome to the RNAV validation tool. My name is Jeremy Davidson. I'm a director of DW International and I'm going to give you a short demonstration of this software tool. The RNAV validation tool is a desktop application that is intended to support the ground validation of performance-based navigation instrument flight procedures. At present it is being configured to do the support on departures and arrival procedures, and we expect to have the approach module complete and fielded before the end of the year. The tool provides two levels. Initially, we have in the navigator on the left-hand side here the ability to enter, create aerodromes, to create runways, and within individual runways to create procedures. We have two procedures here. A double click on the procedure brings it up, and here you see the full procedure. In this case it's an approach procedure. It's one of our beta tests with each leg of the procedure defined, and a double click on the leg brings up another window where you can modify path terminators, turn directions, and all the other aspects that control and define the procedure. On selecting a procedure, the tool automatically runs a series of checks and provides you with a pass-fail report on them. These checks range from simple checks such as the sequence of path terminators to ensure that they are appropriate, to ensure that the RF legs where they are used are defined correctly, to ensure that the distances are appropriate for the legs and the speeds, to ensure that there's adequate data to support each leg, to ensure that the track angle changes do not exceed the constraints defined within PANS-OPS. And here, as you notice, there are some fails that have been identified, and in this case it's where we have failed to provide information on a particular, the true bearing of a track, or where we have not set the altitude modifier on a track. Or here, where an inbound track is not tangential for the arc that we've defined. Some of these fails are ones we can just disregard because we know we haven't provided the data. Others may require us to go back and revisit, but they are set to fairly high tolerances so that it may well be that although this tangential track here has failed, it is still acceptable for the purposes of the procedure. Returning to the procedure, we can also generate a trajectory. We have a number of aircraft types in a performance model, and you can select an aircraft type, determine the weather conditions under which you wish the aircraft to fly, set the default values for the procedure, in this case 150 descending to 10,000, the exit level is 100, and as you start the simulation it's descending to flight level 100. The procedure has been generated. One can now view the aerodrome, and zoom out, and now that's the ground track of the procedure. One can build up a filled wire frame which shows it descending over the ground. One can also view the profile, and here the profile where we get the terrain information underneath the profile and the information on the aircraft performance at each point along it in terms of speed, altitude, and distance to go. One can also fly the profile. We're now starting the approach, and here a small red cross indicates as we're reaching top of descent, and now we start descending. Aircraft briefly arrests its descent to slow down, now maintaining 185, continuing its descent and about to enter the RF turn. The terrain is downloaded from a Whirlwind website at NASA, but can be replaced with other terrain databases, should you wish. Continuing, note the high ground. The aircraft's passing over it, continuing its descent to roll out on final 1 mile from the threshold. RVT. Thank you for taking the time to watch it with me.